In 2014, Brazil spent $290 million to build a massive, state-of-the-art soccer stadium deep in the Amazon rainforest. Today, it sits mostly abandoned. Local fourth-tier football clubs occasionally play on this pitch, but their crowds barely register inside a bowl built for 44,000 people. Keeping a structure of this size operational requires around $250,000 a month in maintenance. With no top-tier local teams to draw crowds, the stadium generates virtually zero revenue to offset that massive overhead. The financial strain became so severe that in January 2023, the local utility company completely severed the stadium's power grid. The operators had defaulted on millions in unpaid electricity bills. The Arena da Amazônia illustrates the trap of bespoke, single-use monuments. Cities take on massive construction costs to host a global event, only to be left with inescapable municipal debt. This financial drain is a systemic feature of how these global tournaments have historically been planned, as seen 4 years earlier in South Africa. Citizens actively protested the public spending required to host the 2010 World Cup, arguing funds should go toward unmet civic needs. Despite the pushback, the city constructed the Cape Town Stadium. Driven by strict requirements for mega events, the final build cost 4.4 billion rand. Following the tournament, the venue operated at an annual deficit of 57.5 million rand. The losses were so severe that the original private operator walked away from a 30-year management lease before it even started. To prevent a total collapse of the asset, the city had to step in. They took direct operational control, injected millions in emergency grants, and rebuilt sections into corporate suites, securing a long-term lease with a local rugby team. This reveals the inherent flaw in historical mega-event architecture. Hosting a 30-day tournament practically guarantees a 30-year financial crisis for the taxpayers. By the 2022 World Cup in Qatar, the sports architecture industry recognized this problem and attempted to engineer a solution, a fully temporary megastructure. This is Stadium 974. It was designed to hold 44,000 fans using a frame of modular shipping containers. The official plan was to completely dismantle the venue after the final match and ship the pieces to a developing nation. But dismantling a structure of this magnitude is incredibly complex. The logistical costs of indexing, shipping, and reassembling tens of thousands of modular components rival the price of simply building a new permanent stadium with local materials. Years after the tournament ended, Stadium 974 remains completely intact on its original Doha site, utilized occasionally as the host country bids on future events. A fully demountable stadium is only a viable solution if the economic and logistical frameworks actually exist to move it. Without that, it becomes another permanent fixture. For the 2026 World Cup across North America, organizers are taking a radically different approach. They have mandated that absolutely no new permanent stadiums will be built for the event. Instead, they are relying on adaptive reuse. The tournament will utilize 16 existing American football and soccer stadiums, upgrading them specifically to meet international standards. This introduces a strict engineering conflict. Standard NFL fields are structurally incompatible with international soccer regulations because the playing surface is simply too narrow. To fit a World Cup pitch inside MetLife Stadium, engineers are physically demolishing 4 corners of the existing precast concrete seating in the lower bowl. Those 1,740 permanent concrete seats are being replaced with a highly engineered modular steel composite seating system. This modular upgrade allows the lower bowl to retract outward, creating the required width for World Cup soccer. Once the tournament ends, the steel frames can extend back toward the field to meet standard NFL capacity requirements. A different challenge exists at Toronto's BMO field, where engineers must temporarily double the stadium's overall capacity. They are achieving this by erecting a massive, heavy-duty scaffolding matrix above the existing architecture. Adaptive reuse solves spatial incompatibilities using temporary steel overlays, meaning cities avoid constructing new, permanent concrete monuments that they cannot maintain. These temporary stadium expansions are powered by a global system known as circular logistics. The physical seats mounted on the temporary scaffolding at BMO Field were not manufactured specifically for the 2026 World Cup. These exact seating assets began their life cycle at the 2024 Paris Olympics. From France, the infrastructure was shipped to New York for the Ryder Cup, before making its way up to Toronto for the World Cup matches. After the tournament concludes, the entire assembly will be dismantled, thoroughly inspected, and shipped across the continent for use in the 2028 Los Angeles Olympics. A modular first mandate changes the basic economics of hosting global sporting events, preventing municipalities from shouldering permanent infrastructure debt. The 2026 World Cup demonstrates that global sporting events do not require permanent concrete monuments. The most sustainable architectural legacy a mega event can have is leaving nothing behind at all.